students, I hope all of you are doing good. Let's start today's chapter, operations involving large numbers. In our previous class, we have learnt about the 4 fundamental operations of addition, subtraction, multiplication and division involving numbers having up to 7 digits. We shall now extend this to large numbers having more than 7 digits. In this book, unless otherwise mentioned, we shall use the Indian place value system. Okay. First, addition. We all are familiar with addition. Okay. We already know how to add numbers up to 1 lakh. Addition of large number is quite similar. We follow the following procedure. Number 1, we arrange the numbers in column. Number 2, then add the digits in each column starting with ones. Take the carryover, if any, to the next column and add it with the digits in that column. We continue till the last column. So, example 1, let's see. First, we'll arrange the numbers in columns, write this like this, and then we'll add the digits in each column like we add. Okay. 7 plus 7 is 14, 1 carry. 6 plus 1, 7 plus 9, 16 plus 8, 24 and then 2 carry. 5 plus 2, 7 plus 8, 15 plus 6, 21, 2 carry. 4 plus 2, 6 plus 7, 13 plus 7, 20. Again, 2 carry. 2 plus 2, 4 plus 6, 10, 1 carry. 1 plus 1, 2 plus 5. 7 plus 5, 12, 1 carry. 1 plus 7, 8 plus 4, 12 plus 4, 16, 1 carry. 3 plus 2, 5 plus 1, 6, 8 plus 1, 9. Okay. Similarly, we will add example in example 2 also. Okay, let's see example 3. A survey shows that the population figures of 3 states are these. Okay, these are the population figures of 3 states. Now, we have to find out what is the total population of the 3 states. In this case, what will we do? We will add the population of 3 states, right? Population of first state, population of this is second state, population of third state, and total population is this. When we will add the population of all the 3 states, okay? Exercise 2.1, you have to add. So, let's add 6 plus 3, 9 plus 3, 12, 1 carry over. 5 plus 1, 6 plus 8, 14 plus 2, 16, 1 carry. 4 plus 1, 5 plus 1, 6. Okay. Okay, let's do here because there is some space problem. So, we will add here 2, 1, 2, 3. Okay. Let's start again. 6 plus 3, 9 plus 3, 12, 1 carry. 5 plus 1, 6 plus 8, 14 plus 2, 16, 1 carry. 4 plus 1, 5 plus 1, 6. Then 7 plus 1 plus 0, 8. 6 plus 7, 13 plus 2, 15. 1 carry over. 2 plus 1, 3 plus 7, 10 plus 1, 11. 1 carry. 1 plus 1, 2 plus 8, 10 plus 7, 17. So, this is the answer, right? Subtraction. To subtract numbers, we follow the procedure given below. Number 1, we arrange the numbers column wise. Number 2, we start subtraction columns wise starting with ones. Number 3, we borrow whenever necessary from the left side of the place. Example 1 is you have to subtract this number from this number. First, you will arrange the numbers in column and then we will start subtraction from the ones place. Okay, and we will borrow wherever needed. It is needed, or we will borrow from the left side of the place. You know that very well. Okay. 2 minus 2 is 0. 7 minus 3 is 4. 3 minus 1 is 2. Okay. Next, 4 minus 6, you cannot subtract a 6 from 4, so you have to borrow from the left digit, which is 6. So, here it becomes 14 and this 5. 14 minus 6 is 8, 5 minus 4 is 1. Now, 4 minus 2 is 2, again 3 is greater than 2, so you cannot subtract, you will borrow from here. 12 minus 3 is 9. 8 is greater than 7, you cannot subtract, then borrow from here. 7 minus 8 is 9 and 17. Oh, 17 minus 8 is 9 and then 8 minus 4 is 4. Okay. Example 2, how much this number is greater than this number? Okay. How much? So, to find the difference between the two, we subtract the smaller number from the bigger one. Whenever we need to find the difference, we always subtract a smaller number from the bigger one. Okay. Example 3, in an election, the winning candidate polled these votes. If the victory margin was this much, find the votes polled by the defeated candidate. Okay. So, total votes were polled and victory margin was this. So, how we will find how many number of votes polled by the defeated candidate. Okay. So, we will subtract these two numbers and then we will get the answer, right? Exercise 2.2, we have to subtract from this number. Okay. Here we are in this chapter, we are using more than 8 digit numbers. Okay. 9, 8, 9, 8, 9. Okay. Now let's subtract. 9 is greater than 7, you cannot subtract, you will have to borrow. 17 minus 9 is 8. Again you will borrow. 10 minus 8 is 2. Again you will borrow. 12 minus 9 is 3. 7 minus 2 is 5. 4 minus 4 is 0. You will borrow from here. 17 minus 8 is 9. 12 minus 9 is 3 and this is 7. So, this is your answer, right? Multiplication. We have learnt in previous classes that multiplication is a repeated addition. The number to be multiplied is called the multiplicand and the number by which it is multiplied is called the multiplier. The result of multiplication is called the product. Okay. See, 5 has been added 5 times repeatedly. Okay. So, we will write 5 into 5. 5 is a multiplier and this 5 is multiplicand and the answer, which is 25, is a product. Okay. The multiplier and multiplicand are also called the factors of the product. Let us read the various properties of multiplication we have learned in previous classes. Number 1, order property. The product of two numbers doesn't change if the order of the numbers multiplied is changed. Okay. For example, 7 into 8 is equals to 56. Let's change the order, that is 8 into 7 is equals to 56. Okay. So, no matter how we multiply, the product remains the same, right? This is called the commutative property of multiplication. Number 2 is grouping property. The product of 3 numbers doesn't change if the grouping of the numbers is changed. So, first we will multiply 8 and 7, then we will multiply the product, that is 56 by 5. So, we will get this answer 280. Okay. And if we multiply first 5 and 8 and then multiply the product, that is 40 by 7, again we will get the same answer. It is called associative property of multiplication. Okay. Number 3 is the multiplicative property of 1. The product of 1 and any number is the number itself. Okay. And it is also called the identity property of multiplication, and 1 is called multiplicative identity. Okay. No matter how big the number is, if whenever you multiply any number by 1, the product remains the number itself. Okay. Number 4, multiplicative property of 0. The product of 0 and any number is 0. 12 into 0 is equals to 0. Okay. Number 5, distributive property of multiplication over addition. Example is 16 into 8 plus 17. Okay. Let's check what does this property say. See, 16 into 8 plus 17. Okay. So, this is the distributive property of multiplication over addition. Okay. So, we will do it like this: 16 into 18 plus 16 into 17. Okay. Number 6, multiplication of a number by 10 and its multiples. To multiply any number by 10, put a 0 on the right of the number. To multiply a number by 100, put 2 zeros. To multiply any number by 1000, put 3 zeros on the right of the number, and so on. Okay. you will multiply by 10,000, then you will have to put 4 zeros on the right of the number, right? Example, multiply, students, how to multiply the numbers, okay? First, we multiply by this number, which is at ones place, then we'll multiply with the second number, which is at tens place, and then after multiplying, after getting the product, we'll add the products, and then we'll finally get the answer, okay? Multiplication by multiples of 10. When one or both factors are multiplied of 10, then we can multiply mentally. Look at the following pattern, okay? See, 5 into 10 is 50. 5 into 100 is, you need not to multiply, just do it orally, okay? And you can multiply mentally. Okay, you will put 2 zeros and 5 into 1 is 5. And when you are multiplying 5 by 1000, then you have to put 3 zeros and 5 into 1 is 5, right? Here also, 2 zeros here and 2 zeros here. How many zeros are there? 4, and then 5 into 1 is 5, okay? 3 into 7, 70 is equals to, you will put 1 zero and then you will multiply 3 and 7, that is 21, right? So, to multiply by multiples of 10, first find the product of the non-zero digits, then write as many zeros after the product as there are zeros in both the factors, okay? What does this say? First, we will multiply the non-zeros. Non-zeros are here, 7 into 3, 21. Now, we will put zeros, okay, after the product. 1, 2, 3, 4. 1, 2, 3, 4, okay. Example 5, find the product. So, you have this number into 300, okay. See, how many zeros are there? 2 zeros, okay. Now, you will multiply this number by 3, right? 3 8s are 24, 2 carry, 3 6s are 18, plus 2, 20, 2 carry, 3 9s are 27, plus 2, 29, and 2 carry, 3 3s are 9, plus 2, 11, okay. So, this is the answer. So, it is really simple to find the product of the multiples of 10, okay. Let's do exercise 2.3. You write the product. You have to multiply these numbers, okay, and you know how to do the multiplication, right? Now, division. Division is the opposite of multiplication. We know that very well. It means sharing equally or distributing equally. The number to be divided is called a dividend. The number which divides is called the divisor, and the result obtained is called the quotient. The number remaining in the end is called the remainder, okay. For example, we are dividing this number 325 by 40, okay. 14 2s are 28, 4, and then we'll bring down 5. 14 3s are 42, okay. So, this is the quotient and this is a remainder, right? Division algorithm to check division, and you can also check your division whether you have done the division correctly or not. So, here is the formula: divisor into quotient plus remainder is equals to dividend, okay, right. So, what is the divisor? Divisor is 14, quotient is 23, and what is the remainder? 3, and it should be equal to 325, which is a dividend, okay. When you multiply these two numbers, we will get 322 plus 3, okay. Now, add 3 to 322, 325, okay. So, both the sides are equal, LHS is equals to RHS, that means your answer is correct, okay. Important facts about division. Number 1, division is repeated subtraction. Example, 91 divided by 9 is equals to 10, remainder 1. It means 9 is subtracted from 91 10 times and 1 is left as a remainder. Number 2, division is the inverse of multiplication, means opposite of multiplication. For example, we have 16 into 8 is equals to 128. If we divide 128 by 16, we get 8, and if we divide 128 by 8, we get 16, okay. See, what does it say? It says 5 into 7 is equals to 35, okay. If we divide 35 by 7, we'll get 5. And if we divide 35 by 5, we'll get 7. Okay, so there is a relation between multiplication and division. Number 3, the dividend, divisor, quotient and remainder are related with each other by the following relationship. Dividend is equals to divisor into quotient plus remainder. Number 4, when we divide a number by 10 and its multiple, we get the numbers formed by as many digits from the right of the dividend as there are zeros in the divisor as a remainder, and the number from the remaining digits of the dividend as a quotient. Example, see, we have to divide this number by 10. Okay, there is 1 0. So starting from the right, we'll consider one digit. This is remainder and the remaining digits are quotient. Okay, and example 2, there are 2 zeros in 100. So from extreme right, 5 3, 35. We have 35 as remainder and the remaining numbers are quotient. Okay, similarly, in thousands case, there are 3 zeros. So 1, 2, 3. 213 is the remainder and remaining digit is quotient. Okay. Number 5, when we divide a number by 1, the quotient is the number itself. Example, 18 divided by 1 is equals to 18. Okay. Number 6, when we divide a number by the number itself except 0, we get the quotient as 1. Okay. Means same number divided by same number is equals to 1. Right. Number 7, division by 0 is not possible. Remember that, since in the process of division, the dividend and the remainder are always equal and quotient can be 0 to any number. 0 divided by any number is 0, means 0 divided by 1 is 0, 0 divided by 50 is equals to 0. Okay. Division by a 2-digit numbers. Example, so we have to divide this number by 48, and 48 is what? A 2-digit number. Okay. So how will we divide? Step 1. Since division has 2 terms, take first 2 terms from the left. 48 goes once in 62. Write 1 in quotient and 48 below 62. Okay. Step 2. 62 minus 48 is equals to 14. Bring down 8. Now 48 goes in 148 at 3 times. Write 3 along with quotient and subtract 144 from 148. So we get 4. Now we'll bring down 9. Bring down next digit 9. 48 goes once in 49. Write 1 in quotient place and 49 minus 48 is equals to 1. Step 4. Bring down 3. We get 13, but 40 doesn't go in it. Put 0 in quotient place and bring down 6. We get 136. Step 5. 48 into 2 is equals to 96. And 136 minus 96 is equals to 40. So quotient is 2 and the remainder is 40. And the final quotient is this and the remainder is 40. Let's do this division. You have to divide by 48. 6, 2, 8, 9, 3, 6. Okay. So there are 2 digits in 48. So we'll first take 2 digits, that is 62. It goes with ones. 48 ones are 48. Now you will subtract. You will get 14. Now bring down 8. Okay. Now it goes 3 times. 48 goes in 148 3 times. 48 3s are 144. Okay. Now we'll bring down 9. 48 ones are 48 1. And we'll bring down 13. Okay. But 13 is smaller than 48. We need to bring down another digit also. But first we will put a 0 here. And then we'll bring down the next digit, that is 6. Okay. So 48 2s are 96. 40. So this is your remainder and this is your quotient. Okay. Similarly, you will divide example 2 also. Now division by a 3-digit numbers. Example is given to you. Procedure, since the divisor has 3 digits, we consider the 4 digits from left. Remaining steps of solution are same as in the previous example. Okay. So let's do it also. See, you have this number 423 and 3, 2, 4, 5, 6, 7, 8. Okay. So there are 3 digits. So we will consider 3 digit here. Okay. But divisor has 3 digits which are 423 and here we will consider 3 to 4, but 3 to 4 is smaller than 4 to 3, so we will consider 4 digits here. Okay, so it goes, okay, you will have to multiply, okay, how many times it goes with the number. So here 7 3s are 21, 2 carry, 7 2s are 14, plus 2 16, 1 carry, 7 4s are 28 and 1 29. Okay, now subtract. Here you will get, now bring down 6. Now 6 3s are 18, 1 carry, 6 2s are 12, plus 1 13, 1 carry, 6 4s are 24, plus 1 25. Okay, then subtract. 16 minus 8 is 8, 0 and 3. Now we'll bring down the next number. Okay, 3087. Okay, so it is near this number, so we'll again take 7. 2961, 6, then 2 and then 1. Then we'll bring down another digit also. Okay, and then here we write 2. 2 3s are 6, 2 2s are 4 and 2 4s are 8. Now subtract 422. So 422 is the remainder and this is the quotient. Okay, now division by multiples of 10. In our previous class we have studied about division by multiples of 10 in detail. Let us recall. 386 divided by 10, there is 1 0, right? So one digit from right becomes a remainder and the rest of the digits are your quotient. Here also you have 2 digits in 100, so from right side there are 2 digits, 89. This is your remainder and the remaining rest of the digits form your quotient, right? And here we have 3 zeros in 1000, so we will take 1 2 3 digits from right as remainder and the remaining number is quotient. Okay, so hence we see that any number divided by 10, quotient all the digits except digit at ones place, remainder digit at ones place. Any number divided by 100, quotient all the digits except digits at tens and ones place and remainder digits at tens and ones place. And any number divided by 1000, quotient all the digits except digits at hundreds, tens and ones place and remainder digits at hundreds, tens and ones place. Example again, here we have a 10,000, so how many zeros we have? 4 zeros. So 1 2 3 4, that is the digit at ones place, a tens place, a hundred place and thousand place becomes your remainder and the remaining digit is a quotient, right? Let's do exercise 2.4. Number 1, divide and find the quotient and remainder. Check your answer using the relation, that is dividend is equals to divisor into quotient plus remainder. Okay, so let's do it. You have this number 3 2 4 5 6. Okay, so there are 2 digits in divisor 87. We will consider 2 digits, but 32 is smaller than 87, so we will consider 4 digits here. Okay, so 87, let's first multiply with 3. Okay, 3 7s are 21, 2 carry, 3 8s are 24, plus 2 26. Okay, let's subtract. 12 minus 6 is 6. Now we'll bring down 5 here. Okay, now 7 7s are 49, 4 carry and 7 8s are 56, plus 4 60. Let's subtract 6 26 and we'll bring down 6 here, right? Now 87 3s are 261, so 5 is your remainder and this is your quotient. Now you have to check your answer also. Dividend, we have this formula, dividend is equals to divisor into quotient plus remainder. What is a divisor? 87. And what is quotient? 373. Plus what is the remainder? 5. It should be equal to 32456. Okay, students, first you will multiply these two numbers and then add a 5 number, and that should be equal to 32,456, right? Simplification. In the simplification of a sum involving operations of plus, minus, multiplication and division, first do division, then multiplication, then addition, and at last subtraction, in that order. We can remember this order as odd mass, ODMAS, where O means of, D means division, M stands for multiplication, A stands for addition, and S stands for subtraction. So we have to follow this order. Okay. However, when brackets are present in a simplification sum, the order is known as odd mass, and we proceed as follows. Okay. If there is if there are brackets present, then we'll write this as odd mass, B for bracket. Okay. So first we perform the operations within the first bracket, that is this bracket. Okay. This is the first bracket. Secondly, we do the operations with the second bracket, which is this curly bracket. Okay. And finally, we do the operations with square brackets, that is these brackets. These are the square brackets. Okay. Notice that this bar is also used as bracket called Wincombe. Okay. The rest of simplification is done using odd mass rule. E. In the brackets also we must follow the odd mass rule. Okay, if there are numbers in a bracket, then there also we have to follow this rule, that is odd mass. Okay, this bracket are often called first brackets, parentheses, or round brackets. And these brackets are called second brackets, braces, or curly brackets. Second brackets often enclose the first brackets. These brackets are called block or square brackets, and this is called bar bracket or Wincombe. Okay. Example 1. Let's do this simplification. Okay. So you have this number 1348 into 4 plus 14,562 divided by 9 plus 1,225 divided by 7 minus 211 into 10. Okay. So first what we gonna do is, what will we do? Rule is odd mass. There is no of. So first we'll do division. Okay. That means we will first divide these two numbers and these two numbers, and we will write other numbers as it is. Okay. We'll write 1348 into 4, and after dividing this we will get what? Okay, write plus as it is, 1618. Then there is sign plus, and here when we divide 1225 by 7 we get 175 minus 211 into 10. Okay. So we have completed the division. Now it's turn to do multiplication. Okay. We'll multiply now. We'll multiply these two numbers and these two numbers. Okay. When after multiplying, we'll get this number 5392 plus this will be as it is. We'll write this as it is. This one also, and minus, oh, it's so simple to multiply because there is 0. I mean 10. 2110. Okay. Now we have done multiplication. Now we will do addition. We will add these numbers, and so what will we get? We'll get 7185 minus 2110, and then finally we will do subtraction, and then we'll get this answer 5075, right? Similarly, in example 2 also we will simplify like this by using the rule of odd mass. Okay, let's do the exercise 2.5. So the first question is simplify. 3456 minus 212 into 121 divided by 11. Okay, so there is a bracket, bod mass. This is the rule. We will, what will we do? We will first solve the bracket. First we will solve the bracket, okay. 3456 minus as it is, and in bracket also we will follow this rule, to mass. So first we will divide these two numbers. 212 multiply 121 divided by 11 is 11, okay. Now multiply 11 twos are 22, 1 carry, 11 ones are 11 plus 1 12, 1 carry, 11 twos are 22 plus 1 23, okay. So 3456 minus 2322, okay. Now subtract. 6 minus 2 is 4, 5 minus 2 is 3, 4 minus 3 is 1, and 3 minus 2 is 1. So 1134 is the answer. Right, students? See, order of bracket is this. First bar bracket and small bracket will be solved, and next is curly bracket, then finally square or block bracket is solved, right? Rounding numbers. Looking back, to round a number to the nearest 10, we use the nearest multiple of 10. To round a number to the nearest 100, we use the nearest multiple of 100. And to round a number to the nearest 1000, we use the nearest multiple of 1000. Example, round 2126 to the nearest 10, 100 and 1000 respectively. Okay. So the multiples of 10 nearest to this number, which is 2126, are what? 200, 120 and 200, 130. Okay, so nearest 10 before 2126 is which one? This one or this one? Obviously this one, okay. So 2126 can be seen as closer to 2130, so it is rounded up to 2130. The shortcut is as under. Rule 1, the round to the nearest 10, check the digit at the ones place, okay. Ones place is digit is 6. It is greater than 5. First replace this number by 0 and then increase this number by 1, that is 3 will get, okay. So rest of the digit will remain same. So this, in this way we will get the rounded number in the shortest way, okay. Round up, since 6 is greater than 5, add 1 to the digit at tens place, replace the ones place by 0. Rule 2, to round to the nearest 100, check the digit at the tens place, okay. 2126, we have to check the digit at what? Tens place, because now we are rounding off nearest 100. 2 is lesser than 5, so no change in the digit at the hundreds place. Replace a digit at tens and ones place by 0, okay, and there will be no change in these digits. So 2100 is the answer, okay. Rule 2, to round to the nearest 1000, check the digit at the hundreds place, okay. 2126, 100 place, there is 1 is less than 5, so there will be no changes. First we will put 3 zeros and 2 will remain 2. So 2000 is a rounded number, okay. Example, round 38,500 to the nearest 1000, okay. Okay, here we will use the shortest method, okay. Nearest 1000, so we will check the number which is at hundreds place, okay. Okay, this digit is equals to 5. Whenever a digit is equals to 5 or greater than 5, what will we do? We will increase 1, we will increase the digit by 1, this one, 9, and 3 will remain 3, and here in these 3 place we will put 3 zeros, okay. So this is the answer. Rounding of large numbers. The same method as discussed above is applied to rounding of large numbers. The following examples will help you to understand it clearly. Example 3. round off each of the following numbers to the nearest 10,000. Okay, you have given two numbers. Okay, in the number 6,82,437, the digit at the thousandth place is 2, which is less than 5. Therefore, we do not make any change in the digit 8 at the 10,000th place and replace the digit 2, 4, 3 and 7 by zeros. Hence, rounded off to 10,000 is this. Let's check. 6,82437, and we have to round this nearest 10,000. Okay, so we will check this number which is at thousandth place. 2 is less than 5. There means there will be no changes on the digits which are left side of 2, that is 68, and we'll put 4 zeros in place of these 4 digits, 1, 2, 3, 4. So this is the answer. Okay, similarly we will do this. 4287532. We have to round off this to nearest thousand. Again we'll check the number which is on thousandth place. 7 is greater than 5. Okay, so what will happen? We will add 1 to this digit which is to the left of 7. So it will become 9. 42 will remain 42, and in place of these 4 digits we will put 4 zeros. So this is the number we get after rounding off to the nearest 10,000. Right, students? Example 4, round off each of the following numbers to the nearest lakh. Here also the same rule applies. Okay, let's do exercise 2.6. Number 1, round off each of the following numbers to the nearest 10,000. So you have this number, 5,29,609. Okay, you have to round off this number to the nearest 10,000. Okay, we will consider the digit which is at thousandth place. This is 9 is greater than 5. Okay, so what we'll add? We will add this number by 1, that is it will become 3 and 5 will remain 5, and we'll put 4 zeros in place of these digits, that is 0, 0, 0, 0. Right? Okay, next is question number 2, round off each of the following numbers to the nearest lakh. Okay, this was question number 1. Now question number 2 is 247,985,9. Okay, now we have to round off to the nearest lakh. So we will consider here the digit which is at 10,000th place. Okay, this is 7. 7 is greater than 5. So we will add 1 to this number. So this becomes 5. 2 will remain 2, and we will write 3 zeros in place of these 5 digits. Okay, 5 zeros. 1, 2, 3, 4, 5. So this is the number after rounding up to the nearest lakh. Okay, students, now you will do practice of the remaining questions.